Now for some area formulas. Okay, if you have a square where all sides are the same and have the length L, the area normally is worked out by working out how many squares fit. Okay, so how many squares fit, and you can work that out quite easily. If you want to do this on a piece of graph paper so you understand it, I recommend it. It's a great way to go. However, I'm going to tell you that it is length squared. Okay, so it is that length multiplied by that length. If you think about it and you had it set up, so I'll draw it a bit bigger over here, okay, where length was 4. Okay, so if we split that into 4 even groups, both ways, not so even, but it'll do. Okay, here is 1 square, 2 squares, 3 squares, 4 squares. Okay, so one line, okay, is 4 squares. And then I have 4 of those lines, which is why we do 4 times 4. So the area of that is 16 squares. Okay, without a unit attached to it, that's all I can say. It's 16 squares. Okay, and that's something I should point out now, is that if you're given units, if I could spell units, units are important. If you're given units, don't forget to put them on your answer, because if you come up with the answer 16 and you don't put a unit on the end, like I have, even though mine's only squares, I've put a unit on the end, then it could be 16 bananas, it could be 16 students, it could be 16 anything. But since I put a unit on the end, it's understandable, it's clear as to what the answer is. So the next area formula you need to worry about is a rectangle. Okay, I might reiterate, area of square equals length squared. Okay, so if we have a rectangle similar to the one we did before, okay, where length and width, and we apply the same principle we just applied with the area of a square, what you will find is if you do the same thing, okay, where we have things like that and crossing over like that as well, the area equals length times width. Very similar to a square. Okay, the area of a rectangle is length times width. Okay, now we start getting to a bit more of the less common ones, and the ones you're less likely to remember from whenever you did this last time. Alright, and that is a parallelogram. Now you'll notice I've put little symbols on there. These little arrowheads mean that these two lines are parallel and never will touch, and these double arrowheads here mean that these two lines are parallel and will never touch. Now there's a really neat trick you can do here, which will explain why the area of a rectangle and the area of a parallelogram have the same formula. Parallelogram, I forgot the L, okay, they use the same formula. If you take this section off here, okay, so this triangle, and actually attach it over here, it's the same area. So if you have the height, okay, of your parallelogram, which in our one over here was width, and you have the length, which is the same as the length there, okay, you can actually work it out. It is written a little bit differently. Area equals length times height instead of width. That's the only difference. The basics are the same because, and again, if you guys want to try this with a bit of paper, draw yourself a parallelogram, cut off that edge there and glue that over here, and you will find that those two triangles fit together and you end up with a rectangle. Trapezium. Okay, is not as easy to remember as the others. Okay, this is length B, A, and you have height. Okay, so if you have a trapezium, the area of a trapezium is 1/2 of A plus B plus the height. times the height, my apologies, times the height. So 1/2 of a plus b times the height. Now again, I can explain this if you would like. What you do is you cut off that section off each of them and rotate it, and it'll fit back up nicely in that section there. So what you're essentially doing here is averaging the lengths of A and B. So you're averaging them, so you're working out what's in between them, and then multiplying by the height. So essentially you're heading back to a rectangle, if you can get back to a rectangle, which you can. And again, try it on paper. Draw yourself a trapezium accurately, and then cut that and that, and they should fit pretty accurately if you cut right up in there and create a nice rectangle, which is why this equation is the way it is. The next one, which you just have to know, and I haven't got a fancy way of explaining this one, is a circle again. Okay, so the area of a circle is pi times the radius squared. Alright, no easy way to explain that unless you want to try and work it out yourself. There is one more before we finish off today, and that is the area of a triangle. Okay, the area of a triangle is the base and the height, and this again links back to being a rectangle. It is 1/2 times the base times the height. If I'll draw you a new triangle and explain why this can be linked back to a rectangle. If I drew my triangle like that, okay, where here is the base and here is the height. If I reflected that and drew another triangle up there, what do you see? You see a rectangle. Now the area of that rectangle is base times height, but we only have half of it here. You can see that this triangle only takes up half of that rectangular space. So therefore, 1/2 times the base times the height. So it seems like all the time that you're going back, except for circle, you can work out how this formula comes about from the square or rectangle formula.